Good afternoon, all of you. So, in the last class, I explained about shear force and bending moment diagrams. So, how to find the shear force at any point on the beam. So, the beam having different types of loads, and the beams also having different types of supports. So, today I'm going to give the explanation about uh, cantilever beams. So, after that, I will give the explanation about the simply supported beam. After that, I will give the explanation about overhanging beams. Today. So after that, I'll give the explanation about the continuous beam and fixed beam, the proper beam data. But most of the problems are given on simply support beam and overhang beams, cantilever beams. So in the last class, I explained about how to calculate your shear force and bending moment for a cantilever beam on the two cases. I've already told you. So that is when a cantilever beam is subject to when a cantilever beam is subject to a point load and cantilever beam is subject to uniform distributed load. So how to find the shear force at any point and how to calculate bending moment at any point. I already told you. So today I'm going to give the third case. Two cases are over. So first one is nothing but this is the cantilever beam which is subject to point load. It is free end. So we are having the shear force and bending moment diagrams like this. So see this one. So this is the load that is equal to W, right? So I have already told you. So for a point load, so if you take any type of beam, what is the shape of the shear force diagram? That is always a rectangle. So we are getting like this. So this is a rectangular shape for a cantilever beam for a point load. So this is the bending moment diagram, which is in the form of a triangle. So it is a linear function. It is a linear function. It is always negative. It's always positive. So according to our sign convention. Okay. One minute, please. Right. Now listen carefully. So this is the shear force diagram, and this one is nothing but bending moment diagram. So for a cantilever beam, so which is subject to point load, and for this second case is also over. So when a cantilever beam is subject to uniform distributed load along its length, entire. So then we are getting the shear force diagram is like this. So observe the shear force diagram here. So the shear force diagram is linear. So it is varies from this point to this point. So this is the shear force diagram I already told you. And in case of bending moment, we are getting the parabola. So this is also negative. This is positive. So these are the two diagrams, shear force and bending moment diagram for the cantilever beam, which is subject to point load, and this is subject to uniformly distributed load. So here today I'm going to give it to you. So when a cantilever beam is subject to uniformly varying load, how to find the shear force and bending moment. After that, I'll give some problems on cantilever beam, how to find the shear force and bending moment, which are given in examination also. So listen carefully here. So this is the cantilever beam, which is subject to uniformly varying load. Right. So for this case, I already told you what is the procedure, how to find the shear force and the bending moment, so that the length of this cantilever beam, I'm going to take it as. L. And this one is the maximum load, that is W per meter. W per meter, that is load at the fixed end. So the load is varies from point to point along the length of the beam. It is always named as uniformly varying load. So here, what I'm saying here, so I want to find the shear force here. I want to find the bending moment here. At the same time, where we are getting the maximum shear force, where we are getting the maximum bending moment, and also we are going to draw the shear force and bending moment diagram. So these are the 4 points. Listen carefully. So what is the first point? I want to find where the shear force is maximum, where the bending moment is maximum. 2 points. And third one is how to draw the shear force diagram and how to draw the bending moment diagram. The 4 points we are going to find for any beam. So the beam is subject to any type of load. So listen carefully here. Okay. All right. So here I want to take one point on this beam here. So I want to cut this beam into 2 parts. I already told you. So I'm going to take the right part. So this is the free body diagram of the right portion of this. So this one is the free body diagram of the right portion. I want to find the shear force bending moment at this point. So listen carefully. So this length I'm going to assume as x, unknown value x. But what is the load here now? So the load is varies from point to point. So what is the load here now? If we take this one, we take this one, we are having two similar triangles. What is the total length here? The total length is nothing but L here. And this one is nothing but W here per meter or per point. So I want to find this value. So this value I'm going to take it as P, that is load at distance of x. So how to calculate here? By using this similar triangle property, that is W divided by L, this load divided by this total length is equal to P divided by X. P divided by X here. Okay, right. So that implies P is equal to how much? W into X divided by L. That is the load here. That is, I'm writing here W into X divided by L here. Now, here I want to find the what is the total load on this beam here. What is the total load on this beam here? This load is in the form of triangle, so that the total load on the beam I'm writing here, the total load on the beam up to a length of x only, I'm saying up to a length of x to length x is equal to, that is I'm writing here, total load TL is equal to total load TL is equal to, what is the area of this triangle now? I'm writing here half into what is the base here? Base is nothing but x here. And what is the height here? Height is nothing but P. What is the P value here? That is W into X divided by L. W into X divided by L. Then what is the total load here? The total load is equal to WX square by how much? 2L. WX square by how much? 2L. That is the total load on this right portion. So I'm writing here, I'm writing storyboard diagram of this portion. Listen carefully. This is the right portion. So this is the total load, but this total load must be passing through its center of gravity. Center of gravity. So here I'm writing Wx square divided by 2L. So this total length is how much? X here. This is the point where we are going to find the shear force bending moment. Or got my point? Right. So how to find the shear force here? So here, so here, so we can draw like this also. Can draw a free body diagram like this also. This is the total load on this beam, that is Wx square by 2L. And here I am going to find shear force and bending moment values. Now tell me, if you see this diagram, so what is the shear force here? Shear force is nothing but sum of upward forces plus sum of downward forces. All of you know very well. In the last class, I explained to you how to find the shear force value. But here, if you see this diagram having only one force, which is acting in downward direction. So here I am going to give the explanation. In the next time, I draw the diagram directly. So if you know this concept very well, we can draw the diagram very easily. So here, what is the upward forces? No upward forces. This becomes zero. So only we have downward forces. How much we have the downward forces? Wx square by 2L. So this is the shear force value at a point at a distance of x. So this is the shear force value. So if you see this equation, that is shear force is equal to Wx square by 2L, it follows the square of the term, that is it follows the parabolic law. So here I'm writing here the shear force varies parabolically. So this is equation number one. Now I want to find the bending moment here. I want to find the bending moment here. What is the bending moment here? So this total length is x and this length is how much here? It is passing through center of gravity. So it is x by 3 and it is nothing but 2x by 3. Why? Because it is a triangular shape. So this is the center of gravity. The center of gravity is at a distance of x by 3 from this side and it is at a distance of 2x by 3 from this side. Okay, right. So here I'm writing x by 3, here I'm writing 2x by 3. Now tell me what is the bending moment value here? Bending moment is equal to this force into this distance. This force into this distance. Now what is the force here? W x square divided by 2L into x by 3. But this force is moving in downward, so the bending moment is negative. I already told you in the last class. So here we are getting W x power 3 divided by 6 times of L, which is negative. So this bending moment follows which profile here? It follows cubic profile. So what is the profile of bending moment here for uniformly varying distributed load? That is nothing but cubic curve. So this is nothing but parabolic curve. So in case of shear force, we are getting parabolic curve. In case of bending moment, we are getting the cubic curve. So depending on the equation of shear force and bending moment, we are going to draw the profiles. So here I'm going to draw the shear force and bending moment. So for example, these are the equation of bending moment and shear force, but I want to find where the shear is maximum, where the bending is maximum. I want to find those two values. Where the shear is maximum, where the bending is maximum. I want to find those two values. So that I'm taking this equation, that is first equation, that is shear force is equal to W x square divided by 2L. Now I'm taking here x equal to 0 here x equal to how much? L. Now I'm putting x equal to 0, shear force is also 0, and x equal to L, shear force is equal to W into L square divided by 2L. L both are cancelled. Again, WL by 2, W L by 2. So we can take here x equal to 2L by 3, or we can take anywhere. That is at the center L by 2, we can take anywhere. Then we can get the shear force value. But here I'm writing at this point, at this point. So what is the bending moment here? Bending moment is equal to minus W x power 3 divided by 6 times of L. Then I'm writing here at x equal to 0, bending moment is also 0. And x equal to L, bending moment is nothing but how much? Minus W L power 3 divided by 6 times of L. Both are cancelled. Then W L square divided by 6. So that is the value of bending moment. So I want to draw the so two points is clear. What is the value of shear force and what is the value of bending moment and where the shear is maximum, where the bending is maximum. This is clear. So where the shear is maximum at x equal to L is shear is maximum. At x equal to L, bending moment also maximum. That is at x equal to L means that is at support. At this support, the shear force and bending moment both are maximum in case of cantilever beam. Or got my point? Now I want to draw the shear force and bending moment diagram for this case. So if I want to draw the shear force and bending moment diagram, so depending on the profile of the shear force equation and bending moment equation, bending moment equation. Or got it? Now tell me here, this is the shear force I am drawing. Or you got it? So here shear force is at this point is 0 and at this point is nothing but how much? WL by 2. WL by 2 means positive. That is, I am going to indicate WL by 2 is positive. Now I'm going to join these 2 points by a parabola like this. This is a parabolic form. So you got it. Now I'm going to draw the bending moment diagram. So at this point, at x equal to 0, bending moment is 0. But at x equal to L, we are getting the bending moment is WL square by 6, which is negative. I'm going to join this one is a cubic curve. So the slope is different from the parabola. So only slopes are different so that it is a cubic curve. So in case of uniformly distributed load, we are getting the bending moment diagram is nothing but parabola. So listen carefully here. What you observe here, I'm going to give it to you in a simple way how to remember the shear force and bending moment diagrams. So this is the way of calculation of shear force and bending moment and how to calculate maximum shear force and maximum bending moment where we are getting and how to draw the shear force and bending moment diagram depending on the two equation that is shear force equation and bending moment equation. All right, so listen carefully. I want to give it to you simple table. Remember the table, then we can automatically draw the shear force and bending diagram. Okay, right. Listen carefully. So here I'm writing load. Here I'm writing shear force diagram, SFD, and here I'm writing bending moment diagram. Bending moment diagram. So in case of point load, so if you take any type of beam, when the beam is subject to a point load, then what is the shape of the shear force diagram? It is always rectangle. Remember that one. It is always a rectangle. What is the below diagram? Triangle. So if you take any type of beam, so many types of beams we are having? So six types of beams. Whatever the beam we have taken, so that beam is subject to a point load, then the shear force diagram must be rectangle and minimum diagram must be triangle. And when the load is said to be uniformly distributed load, when the load is said to be uniformly distributed load, and the shear force diagram is triangle, it will comes here. It's a triangle and parabola. Bending diagram is nothing but parabola. Or you got my point or not? So in case of uniformly varying load, so in case of uniformly varying load, the shear force diagram is nothing but this one is comes here now, that is parabola, and next one is nothing but cubic profile, cubic curve. So if you remember this table, so we can draw the shear force and minimum diagram so very easily. So where the point load is there, we can draw the shear force diagram is a rectangle and minimum diagram is triangle. Where the uniform distributed load is there, so shear force diagram is triangle and minimum diagram is parabola. So where the varying distributed load is acting on the beam, whatever the beam it is, whether it is cantilever, simply screw, whatever the beam it is, then the shear force diagram is parabola and minimum diagram is cubic profile. So here, remember this table now. So now I'm going to give some problems on cantilever beam. Uh, Cantilever beam, how to solve shear force and bending moment values. So listen carefully here. So this is the one another example problem on cantilever beam. So this is the cantilever beam which is subject to load like this. And here another load is there. This one is 2 kilonewtons and this one is 3 kilonewtons. And it is making an angle of 45 degrees with the vertical. So this is the force which is inclined at an angle of 45 and this force having load of 3 kilonewtons and this force having a load of 2 kilonewtons. And the distance between these two is nothing but 1 meter. The distance between these two is nothing but 1 meter. Now here I want to draw the shear force and bending moment diagram. They will ask simply draw the shear force and bending moment diagram. Otherwise, they will ask what is the shear force at a certain point. I'm taking this point is A, this point is B, this point is C. They will ask any type of question. They will ask only shear force diagram. They will ask only bending diagram. They will ask what is the maximum shear force, what is the maximum bending moment in this beam. So where we are getting the maximum shear force, where we are getting the maximum minimum. For cantilever beam, we can remember easily, we are always getting the shear force maximum at the support and minimum is also maximum at the support. So very clearly I am saying, so listen carefully. Now what I am saying here, how to calculate. So listen carefully. So here, this one is inclined. What is the definition of beam here? Beam is always subject to normal loads. Beam is subject to always normal loads, but it is not normal, it is inclined. So that I'm going to resolve this one into two components. One is along vertical direction and one is along horizontal direction. But in case of shear force and bending moment, we are not consider the horizontal forces. We are always consider vertical forces. That is downward forces or upward forces. But forces are perpendicular to the beam. Now tell me here how much value we are getting here. That is 3 cos 45 degrees and this one is 3 sine 45 degrees. Now I'm going to draw the free body diagram of this one. Okay. So this one is the load that is equal to 2 kilonewtons and this is the vertical load. I'm going to replace by this one. This is 3 cos 45. That is 3 cos 45. The distance is nothing but 1 meter. This distance is nothing but 1 meter. This is point A, this is point B, this is point C. Now listen carefully. I'm going to explain step by step. So in the next time I will draw the diagram directly. Listen carefully. So here I'm writing that is shear force at C. Shear force at C I'm saying. How many forces are acting at point C now? Only one force is acting in vertically downward direction. So I'm writing here 3 cos 45 degrees. That is 3 into 1 by root 2. That is 3 by root 2 is the value of shear force at C. Now I'm writing here shear force at B. At B means, so if you want to find the B here, generally procedure is we have to divide this beam into two parts at point B. So we are coming from right to left. So that if you take point B, how many forces are acting now? Up to this one now, up to B I am taking here. So how many forces acting up to B on this beam? I am taking B point. So this is the right portion I am taking here. So on this portion, how many forces are acting here? Two forces are acting. So that shear force at point B is nothing but that is 3 cos 45 degrees plus 2 kilonewtons. Why? Because shear force is nothing but sum of upward forces and downward forces. Sum of upward forces and downward forces. So here I am writing here. So 3 by root 2 plus kilonewtons. That is the value of shear force at B. And what is the shear force at C now? That is sorry A now. That is sum of the all the forces, sum of the all the upward force and downward forces. Here is also what is the shear force at A now? So sum of these two again, same we can get it. But here, one more force is there, that is the reactive force. What the reactive force is? Same value. So this reactive force is also is equal to 3 by root 2 plus how much? 2 kilonewton. This is acting in upward direction. This total force is acting in downward force. So this force plus this force, total force is acting in downward. That is the active force. And this is the reactive force. But if you take it any at a point A, what is the shear force here? We are writing 3 by root 2 plus 2. This is positive minus 3 by root 2 plus 2. This is negative, which is moving in upward direction. So these two are cancelled and equal to how much? 0. Or you got my point or not? So here, shear force to point C is clear, point B is clear, point A is also clear. Or you got my point? So how to draw the diagram here? So I want to draw the shear force diagram directly. Listen carefully. So here, I'm going to draw shear force diagram. What is the shear force diagram here? So 3 by root 2, which is positive. So up to this one is positive. That is 3 by root 2. And up to this one is that load is same. If you come to this point, load will increase. How much load will increase here? 2 kilonewtons will add it. So 2 kilonewtons will increase here. That is nothing but 3 by 2 plus 3 by root 2 plus 2. And this load is continuous up to this one. So see this one, I'm drawing a rectangle. I'm drawing a rectangle here. Why? Because so it is a point load, shear force diagram. If you come to this point, then it comes to zero here. So this is the shear force diagram for this beam. For got my point? Directly we can draw it, no problem. But I have given an explanation of how to find the shear force values at every point. So now this is the way of drawing the shear force diagram. Now I want to find the bending moment at every point. Now tell me where we are getting the shear force maximum at this support without taking the reaction. If you take the reaction and both are get cancelled, the shear force becomes zero. Or get my point or not? Then this beam is said to be under equilibrium condition. So that is the shear force diagram. Now I'm going to explain to you what is the bending moment diagram here. So I want to find the bending moment at C and B and A. Listen carefully. So I'm writing here bending moment at point C. At point C means this force is passing through this point. So there is no any perpendicular distance between the point and the force. So bending moment must be equal to how much? Zero. Are you got it? Right. And I'm going to write bending moment at point B. Listen carefully. If you want to find the point B here. So this force is passing through point B. So this moment is zero. But this force is not passing through point B. This force is at a distance of 1 meter away from the point B. So that there must be a moment with respect to this force, taking the point of B. And this moment of this force must be zero. So if you divide this beam into two parts, then we are getting the two forces like this generally. That is two force we are getting. This is 3 by root 2 and this one is 2 kilonewtons. This is point B. But what is the moment of this force with respect to B? Zero. But this moment is not zero. So I am telling you, so moment of this force is nothing but that is 3 by root 2 into 1, which is negative. Why? Because this force is moving in downward direction. So this is the value of minus 3 by root 2 Newton meter, kilonewton meter. Right. Now bending moment at point A. I am taking at point A now. So if you take the point A, there must be a bending moment with bending moment of this force with respect to this point. There must be a bending moment of this force with respect to this point. So this force into this distance, that is 3 by root 2, 3 by root 2 into total distance. What is the total distance? 1 plus 1, that is 2, which is negative. And this is also moving in downward, that is 2 into. And distance between these nothing but 1, which is also negative. And here, how much value we are getting here? That is 2 here. That implies uh, root 3 into 2 we get it minus 2 we get it. So this is the way of calculation of bending moment at every point. Now tell me here. So these are the point loads. Point loads. I want to draw the bending moment diagram here with respect to these values. Now listen carefully. I want to draw. So here, okay, right. So this is the reference line. Now tell me what is the bend moment here? Zero. Bend moment is zero here. And what is the bend moment here? So 3 by root 2, but which is minus. Here we are getting downward minus. This point is minus 3 by root 2. Okay, right. What is the bend moment at point A? That is, we are having minus 3 by root, that is 3 root 2 minus 2 here now. So how to join these 2 points here? How to join these 2 points linear? Why? Because it is a triangle here. It is a triangle here. So this is the bending moment diagram. Are you get my point or not? So this value is always more than this value. Or you got it? So that this is the way of drawing of bend moment diagram for this case. Now here I'm going to give you one more example on cantilever beam. So listen carefully. So this is the cantilever beam. For example, up to this one is nothing but uniform distributed load, and up to this one is a point load is acting. At this point is also another point load is acting. It is 2 kilonewtons. It is also 2 kilonewtons, but the distance between these two is 1 meter. But this load is 2 kilonewton per meter, and this distance is also 2 meters. Now tell me, what is the shear force diagram? What is the bend diagram directly? So first of all, I'm going to draw the shear force and bend diagram directly. After that, I will explain you so how to get that values. So here, this is the shear force diagram. Here, shear force is 2, which is moving in downward positive. So I'm going to upward direction. This is 2 kilonewtons is the shear force at point. This one. This is point A, point B. We can take point C here. Up to this one is same rectangle. If we come to this point, another load will add it. That is 2 plus 2, 4. So up to this one, I'm going to like this. This one is 4 kilonewtons. Why? Because shear force is always sum of the upward forces and downward forces. Okay. All right. So if we come to this one, the load is added, but this load is uniformly distributed load. So what is the shape of this shear force diagram? Triangle. I got my point or not? So this is the shear force diagram for this thing. We can draw directly. Now, how to draw the minimum diagram? What is the shear force here? Shear force here is so sum of all the forces. Now add it 2 plus 2, 4, and 2 into 2 meters and 4. So 4 plus 4. The total is shear force is 2 plus 2 plus and 2. This is kilonewton per meter, but how much length of this uniform distributed load? 2 meters. So 2 into 2. That is totally 4. That is 8 kilonewtons is the maximum shear force here. Which is here 8 kilonewtons. This point is nothing but 4 kilonewtons. This point is nothing but 2 kilonewtons. So 2 kilonewtons at point C, and at point B is nothing but 4 kilonewtons. At point A is nothing but 8 kilonewtons. Now tell me what is the maximum shear force here? 8. That is always at the fixed support. Now tell me what is the bending moment diagram? Bending moment diagram. Now if it is a rectangle, it must be triangle. Or get my point or not? And what is this one now? This one is nothing but UDL. UDL means it is a parabola. Is a parabola. Or you got my point or not? Or you got it? But we have to find the value of bending moment here, here, and here. This point is C, this point is B, this point is A. Then what is the banks of bending? This is the bending moment diagram. Up to this one is linear. Up to this one is a parabolic function. It is a parabola. So this is the bending moment diagram. Now, how to find the bending moment here? So we know that bending moment at this point is zero. Why? Because I'm writing here bending moment at point C is zero. Why? Because this force is passing through point C. Point C. Then that bending moment is zero. Then what is the bending moment at a point B now? What is the bending moment at point B now? So this force into this distance, that is 2 into 1 meter, which is negative. Why? Because that force is moving in downward. That is a sign convention of bending moment. And this force is passing through point B. So this force moment must be zero. So at point B, we are getting only 2 kilonewton meter is the bending moment value. And what is the bending moment? What is the bending moment at A? What is the bending moment at A? Or you got it? Right. Now tell me at A point, this force into this entire length, that is I'm writing here. Carefully. So I'm writing bending moment at point A is equal to this force into this distance, that is 2 into, that is 3 total distance, minus, and this force into this distance, that is 2 into 2, which is also minus. Okay. And this one, what is this one? Uniform distributed load. What is the total load here? 2 into 2, 4. Convert into point load. This is 2 kilonewtons per meter, but here is length is 2 meters. Per meter is 2 kilonewtons, but 2 meter is 4 kilonewtons. So this 4 is exactly acting at the center. This is 4 kilonewtons is the total load on this portion only. That is the total load on this portion. This load exact acting at the center. So what is this length now? This length is equal to 1 meter, half of its length. Then this force into this distance. So I'm writing here that is 4 into 1, which is a negative. Then I'm writing minus 6, minus 4, minus 4. Then that is minus 14 kilonewton meter is the bending moment value. What is this value here? 0. And what is this value here? Minus 2 kilonewtons meter. And what is this value here? At point A. So at this point we are getting minus 14 kilonewton meter is the value. You got it? Right. So this is the way of drawing the shear force and bending moment diagram. I want to give one more example on this one, on the cantilever beam. So they will ask only what is the maximum bending moment, what is the shear force diagram here. Listen carefully. So this is the cantilever beam. Here, one load is acting here. The load is equal to 2 kilonewtons. And this one is nothing but 1 kilonewton per meter. And the distance between these 2 points is 2 meters, and it is also 2 meters. This point is A, this point is B, and this point is C. Now don't calculate the shear force and bending moment value. So draw the shear force and bending moment diagram here. So here I'm going to draw directly. So what is the shear force and bending moment diagram? So first of all, I'm going to draw the shear force diagram. So here shear force is 0. So from this point to this point, which load is acting on the beam? That is uniformly distributed load. So that load your UDL, that is uniformly distributed load. So for the uniform distributed load, what is the shear force diagram? What is the shear force diagram now? That is triangle. Okay. So here is 0. I'm getting here now. Up to this one is nothing but uniformly distributed load. So what is the value of shear force here? We can say directly. That is this load is 1 kilonewton per meter. For 2 meters, 2. So I can write 2 kilonewtons is the shear force. But if you come to the point B, another load is added here. So I'm going to add another load here now. That is, it is 2 kilonewtons. And this load 2 is added. So it is 4 kilonewtons. One load is added here at point B. So again from B to A point, again it is UDA. So I'm going to indicate here, again it is a triangle because the shear force diagram is a triangle. But what is the total load here at point A? So add so 2, this is total 2 plus 2, 4. After this one is 4 and add this remaining here. After this one is 4 kilonewtons, all of you know. But add this one is also. This one is how much? 2 meters into 1. Again, 2 here. So I'm writing here at point A. So 4 plus, again, 2 into 1. Why? Because load is 1 kilonewton per meter, but this length is 2 meters. So 2 into 1, that we can get 2. So total is nothing but 6 kilonewtons is the total shear force at point A. At point A. Are you got it? Right. So this is the shear force diagram. So listen carefully here. We can draw very easily now. Now tell me how to draw the bending moment diagram for this case. How to draw the bending moment diagram. So Here, uniform distributed load, so it is simply parabola. Okay, here is also uniform distributed load, so it is also continuous. You can draw the parabola like this. From this point is also parabola. From this point is also parabola. So this is the bending moment diagram. But I want to find the bending moment here. I want to find the bending moment here. Now tell me very simple case. What is the bending moment here? What is the bending moment here now? Now tell me what is the total load here? 2 into 1. That is a 2 total load. The total load must be acting at this point center. Why? Because it is a UDL. This is 2. But this load into this point, reference point, that is 2 into half of this value, 1 meter. Half of this value, 1 meter. Or you got my point or not? The total load is nothing but 2 into 1, that is 2 kilonewtons. The 2 kilonewtons must be acting at its center. And this force into this distance. This is half of this value, half of this total entire length of this. So here writing 2 into 1. So I'm writing here bending moment. I'm writing here, listen carefully. So bending moment at B is equal to, so 2 into 1 again into 1. This is 2 into 1 means this is length is 2 meters and load is 1 kilonewtons. This is the total load up to 2 meters and into this one is the half of the distance 1 meter. It is also 1 meter. So bending moment is nothing but load into the perpendicular distance which is negative. So I'm writing here minus 2 kilonewton meter is the bending moment at point B. Now, what is the bending moment at point A now? A now. So, what is the bending moment at point A? So, listen carefully here. This load is 2 into distance is 2 minus 1 load is over. And what is the total load here? What is the total load here? So, total load is nothing but 1 into total distance. 4. This is the total load on this beam due to UDL. So that is also acting at this point, at the center. So half of this value again into 2 minus. Are you got it? What is the total load here? Total load of EDL, that is 1 into 4. 1 into 4 means 4 meters length. That is also acting at the same point. Why? Because it is UDL which is exactly acting at its center. So it is also 2 meters distance. It is also 2 meter distance. Then this load 4 into 1 into 2. So we can write here minus 4 and minus 8. Then we can get minus 12 kilonewton meter. So that is the maximum bending moment here. Minus 12 kilonewton meter is the maximum bending moment value. So we can draw directly without any calculation. If they ask me what is the maximum bending moment, what is the maximum shear force, then we can calculate very easily by step by step. Or you got my point? Okay. So these are the some problems on simply cantilever beam, which is subject to a point load like this. Now here I'm going to give it to you. So simply supported beams now. So for example, I'm taking this as a simply supported beam. Case one, I'm taking case one. This is a simply supported beam, which is simply placed over the support. So this beam is subject to a load exactly at the center. This one is nothing but L by 2. And this one is nothing but L by 2. So all of you know very well. So I think all of you know it. So how to calculate, if any simply supported beam is given to you, first of all, calculate the reactions at the support. After that, we can draw the shear force and bend moment diagram. So I will give the explanation for this. Remaining also I will give the direct formulas for reactions and I will give the shear force and bending moment diagrams. Okay, listen carefully. I will give the explanation for this, how to calculate the reactions and the support. So here I am taking the support is A and support is B. So when the beam is said to be under equilibrium condition, then we know that sum of upward forces is equal to sum of downward forces. So first equation I'm going to write sum of upward forces is equal to sum of downward forces. Or we can write sigma y is also 0. So here it is a roller support. So it is having one reaction. It is also having one reaction. So it is RA and it is I am writing RB. So I am writing here sum of the upward forces must be is equal to sum of the downward forces. So I am writing here RA plus RB is equal to W. This is the equation number one. So here I want to find how many variables here. I want to find the two variables RA and RB. I want to find two variables RA and RB. But if you want to find the two variables RA and RB, so how many equations are required? Two equations are required in terms of RA and RB. So that I want to write another equation in terms of RA and RB. So that I'm going to use the second one. Moment about any point is zero. Moment about any point. We can take about B, about C, or about A. We can take anywhere. But I am taking moment about A is 0. I am taking. We can take anywhere, no problem. So I am taking moment about A point is 0. Then what is the moment of RB here? That is RB into how much total length is L? That is positive. Why? Because it is anti-clockwise direction. So and W into L by 2. This is the force and this is the distance. This is the force and distance. Then I am writing here L by 2, which is negative, must be equal to 0. Then I am writing here RB into L is equal to W into L by 2. So LL both are cancelled. Then I am writing RB is equal to how much? W by 2. So this is the way of calculation of RB. If you know the RB value, automatically if you substitute in that equation, then we can get RA. RA is also we are getting here. RA is also is equal to W by 2. So here, in this case, there is no any need of calculation of this one, but if the load is not acting exactly at the center, we can follow like. If it is acting exactly at the center, we can take directly this reaction, the reaction both are shared the load half of equally share the load now. So that directly I am writing here, this one is RB is W by 2 and this one is also is equal to W by 2. So, but if any problem is given on simply support beam, first of all, we are going to calculate reactions at the support. So listen carefully, okay? What I am saying here, first of all, you have to calculate reactions at the support. After that, we can draw the shear force and bending moment diagram also, okay? Right. So now here, I'm going to draw the shear force and bending moment diagram for this case. Now tell me here, so these are the values of reactions. Now tell me here, what is the shear force value here? Here this force is moving in upward. Force is moving in upward. So shear is negative. I already told you. If the force is moving in downward, shear is positive. We can take in upward direction. So it is minus W by 2. So up to this one is the same load will continue. If we come to this point, this load and this load we can add it. Why? Because shear force is nothing but sum of all the forces. If we come to this point C, add this load and this load. How much we get now? Here I am writing W is positive minus W by 2. We can get plus W by 2. If we add it, we are getting W, this load is moving in downward, positive, and this load is moving in upward, negative. W minus W by 2, we are getting plus W by 2. So this value is how much? Minus W by 2, but we are getting plus W by 2. So I'm going to first of all 0, again I'm going to plus W by 2. So this is plus W by 2. I got it? So up to this one is same here. And if we come to this point, plus W by 2, again here, this is moving in upward, minus W by 2, both are cancelled. This is 0, come to 0. So this is the shear force diagram for simply supported beam when the load is exactly at this center. I'll give it to you when the load is not acting exactly at the center, how to calculate it. I will give it to you later also. Okay, all right. So this is a shear force diagram. Now here, what is the bending moment diagram? What is the bending moment diagram? So listen carefully. If any simply supported beam is given, so bending moment must be zero at the supports. Simply support beam is given. Remember one thing. So bending moment at the two supports must be zero. Why? Because this force is passing through this point. Moment is zero. Otherwise, I'll explain you. Listen carefully. But you have to remember it. What I am saying. Moment at the supports must be equal to how much? Zero. So this is the bending moment diagram. I'll explain you how to get the those values. Bending moment at this point is zero, and the bending moment at this point is also zero. But what is the bending moment at the center now? If you take from this side or from this side, we can get the same magnitude, but directions are opposite. So tell me, what is the moment of this force with respect to this point? That is WL by 2 into L by 2, that is WL by 4. I got my point or not? W L by 4. Okay, right. So here is W L by 4. I'm writing here W L by 4. From this side also we are getting W L by 4. But how to join these 2 points? These 2 points. It is a point load. So Benjamin diagram is a triangle. So this is the bending moment diagram. Or get my point or not? I got it? Right. So that is the bending moment diagram. But now I want to find the values of bending moment here now. So I want to take bending moment about B must be is equal to 0. Why? Because that force is passing through that point. There is no moment. So I'm writing here bending moment at point C. So this force is passing through C. This moment is 0, but this moment is not 0. So that WL by 2 into how much? L by 2. But this force is moving in upward. So it is positive. Then we are getting here a WL by how much? 4, which is positive. So see this one, this is positive. Now I am writing here bending moment at point A. Now tell me what is the bending moment at point A? This force into this distance. This force into this distance. That is W by 2 into L. Total length is L, which is positive moving in upward direction. And this load W into how much? L by 2. It is negative. So these two are cancelled and equal to how much? 0. Are you clear now? So if any simply support beam is given, simply we can say that supports bending moment must be equal to 0. Okay, so I have already told you how to draw the shear force diagram and how to draw the bending moment diagram. I have already told you. Now here, when this simply support beam is subject to a eccentric load, that is, the load does not act exactly at the center. If it is eccentric load, how to draw the shear force and bending moment diagram? See this one. So this is the simply support beam. This is the load which is acting here. That is 5 kilonewtons. I am taking. This is 3. This is 2 meters, and this is 3 meters. This point is A. This point is B, and this point is C. I am taking. Now here I want to find the shear force and bending moment here. Okay. So what is the bending moment diagram here? So simply we can draw here. So this is the minimum diagram. What the first of all shear force diagram? If you want to draw the shear force diagram, first of all find these two reactions. I got my point or not? Right. So after finding the reactions only, we can draw the shear force and bending moment diagrams. Now how to find the reactions here? So here one more on the reaction here RA, and here one more reaction, that is nothing but RB. So I'm going to use two equations, that is nothing but RA plus RB is equal to 5. That is sum of upward forces is equal to sum of downward forces. Okay, right. And the second equation is nothing but take moment about A is equal to 0. We can take anywhere, but I am taking it point A is 0. Then this RB into total, that is RB into total distance is 5, which is positive. Why? Because this force is moving in upward direction, minus this load. Why? Because why I'm writing minus, this load is acting downward. That is 5 into 2 is equal to 0. Then RB into 5 is equal to 5 into 2. Both are cancelled. Then we are getting RB is equal to how much? RB is equal to how much? 2. Or you got my point or not? Right. That is 2 kilonewtons RB value. And what is the RA value? RA value automatically 3. So I am writing here RA is equal to 3 kilonewtons. So this is the way of calculation of RA and RB. So we can calculate it within a few seconds. We can calculate the value of RA and RB when any simply support beam is given. So now I am getting RA is more, RB is less. RA is nothing but 3 kilonewtons. I am indicating here. Listen carefully. So here I am indicating RA is, this is 3 kilonewtons and this is 2 kilonewtons. Now tell me what is the shear force and bending moment diagram for this. Don't calculate any value. So draw the diagram only now here. Now here this is the shear force diagram. So this force is acting in upward, shear is negative. I'm going to draw up to this one, minus 2 kilonewtons. And up to this one is a rectangle, where it is a point load. If you come to this one, so this one is negative, this one is positive. Here we are getting plus 3 kilonewtons. Or you get it? So here 5 is positive and 2 is negative. So if you take the point C here, add these two. This is positive, this is negative. So 5 minus 2, 3, positive. So that it is negative minus 2. And first of all comes to 0 and goes to plus 3. And again 3 is constant here and it will comes to up to this point and again 0. So this is the shear force. Okay, right. Now I am going to draw the bending moment diagram here. Bending moment diagram. Now tell me here. For a simply supported beam, I have already told you, for a simply supported beam, bending moment at the two supports must be 0. So here is 0, here is 0. Now tell me here, what is the moment about C here? What is the moment about C here? What is the moment about C here? Now tell me here. Are you got it? Right. So here, what is the bending moment about this point and this point 0? But what is the bending moment about C here? Now tell me what is the bending moment about 2 into from this side? That is 2 into how much? 2 into 3. How much you get? 6. And from this side also, listen carefully. From this side, this is 3. 3 into 2. 6. We are getting same magnitude, but directions are opposite. So that if you come to this side, first of all, it comes to which one now? So that is 3 into 6 positive. It is also positive. Then I'm going to indicate that. So both are 0 here. This is nothing but 6 kilonewton meter is positive value. So that is the bending moment diagram for this case. This is the diagram I am drawing. I am always coming from right to left. If you coming from left to right, this is in downward direction. Why? Because we are taking negative value. Or you got my point or not? So this is the way of drawing shear force and bending moment diagram when the load is away from the center. Okay, right. So this is about simply support beam. So when the load is point load, one is like exactly acting at the center, other one is away from the center, that is a centric load. Now I'm going to explain about the case number 2 here. That is case number 2. That is simply support beam, which is subject to uniform distributed load. So listen carefully. In shear force and bending moment having only 5 models. When the beam is subject to point load, when the beam is subject to UDL, when the beam is subject to UDL, and the beam is subject to couple, when the beam is subject to internal hinge. These are the 5 cases we are going to deal in any competitive exam. So almost they will give the questions on this one only. So you have to remember, one is beam is subject to point load, beam is subject to UDL, beam is subject to UVL,
beam is subject to couple. I will give it to you when the beam is subject to couple, how to draw the shear force and bending moment diagram. And the last one is internal hinge. When the two beams are connected by a hinge and the middle of the beam we are having hinge, that is nothing but internal hinge. How to draw the shear force and bending moment diagram. So now here, this is the simply supported beam which is subject to a uniformly distributed load. So this load is equal to how much? W per meter. Now tell me here, what is the total load here on the beam? That is total load is equal to how much? Total load is equal to WL. But if it is said to be uniformly distributed load, the total load must be passing at the center. So at the center, or you got my point or not? So this total length is equal to how much? L here, this is the total length. So what is the reactions here now? So we can say when the total load is WL, when it is exactly acting at the center, why? Because it is uniformly distributed load that is always passing through its center. Then automatically I can take this load is nothing but WL by 2. This load is also is equal to WL by 2 of that reactions now. So this is equal to RA and this is equal to R. Or you got my point or? Right. So here how to find the shear force maximum value, how to find the bending moment maximum value, how to draw the shear force diagram, and how to draw the bending moment diagram. So here, first of all, I'm going to draw the shear force diagram. Right? You can draw directly. This is WL by 2, and this is WL by 2. I'm going to draw the shear force diagram for this case. Now tell me here, what is the shear force at this point? WL by 2, which is moving in upward. So shear force is negative up to this one now. That is minus WL by 2. So here, what is the shear force here now? If we calculate like this, so we are getting the point here. That is also plus WL by 2. I will give it to you later. Listen carefully. And these 2 points are joined by a linear profile. Why? Because it is a triangle. Shear force diagram is a triangle. At this point, shear force must be equal to how much? 0. Now I will give it to you. So listen carefully. This point is A, this point is B, this point is I am saying C. Now how to calculate those values? How we get the W minus WL by 2 plus WL by 2 at point C is 0. I'll give the explanation. See this one. What is the procedure here? What is the procedure here? Generally, I am taking one point here. I'm going to cut the beam into two parts. Listen carefully. Okay. So here I'm writing this portion. This is the portion. This load is nothing but double reaction is WL by 2. And this is the UDL, that is W per meter. And this one is we are going to assume as X. Now, what is the total load on this beam up to this portion? So I'm going to draw again free body diagram. This is WL by 2. And this load is exact lighting at the center. It is X by 2. It is also X by 2. And this load is nothing but how much here? W into X. That is for unit length. This is for length of X. That is the total load, exact lighting at the center. This length is X by 2. This length is X by 2. And I want to find the shear force at this point and bending moment at this point. Now listen carefully here. So here I am taking X equal to 0. Here I am taking X equal to L. Now I am going to find the shear force equation. I am going to find the bending moment equation. We can draw directly. Otherwise, we can follow like this also. So here a shear force is equal to how much? From this diagram, shear force is equal to sum of the forces. One is upward, one is downward. Downward is positive, that is Wx minus WL by 2. This is the shear force equation. Now I am writing here when x equal to 0. Tell me when x equal to 0, what is the value we get? Shear force is equal to minus WL by 2. Now tell me at x equal to L, at x equal to L, what is the shear force value? At x equal to L means it is WL minus WL by 2. Then we are getting shear force is equal to plus WL by 2. See this diagram? Here we are getting minus WL by 2. Here we are getting plus WL by 2. I got my point or not? Now at x equal to L by 2, how much you will get? At x equal to L by 2, WL by 2 minus WL by 2 both are cancelled. So here is this distance is nothing but how much? L by 2. At x equal to L by 2, shear force must be 0. But where the shear force is 0, bending moment is maximum. I'll give it to you how to calculate that value also. Or you got my point? Now I'm going to use the same diagram. I want to find the bending moment here. At x equal to L by 2, shear force must be 0. So here I'm going to use the same diagram. I want to find the bending moment values. Listen carefully. So what is the bending moment here? Bending moment equation. Bending moment is equal to, see this one, this force into this distance. That is WL by 2 into x, which is positive. Why? Because it is moving in upward. And what is this one? W into x by 2. This is Wx, which is moving in downward direction. This distance is nothing but x by 2. Then we are getting Wx into x by 2. Then we are getting WLx by 2 minus Wx square by 2. This is the equation of bending moment. Now I want to find what is the bending moment at x equal to 0, at x equal to L. Listen carefully here now. At x equal to 0, what is the value of bending moment? Tell me from this equation. 0. So at x equal to L also, what is the bending moment value? 0. Now at x equal to L by 2, what is the value of bending moment now here? At x equal to L by 2, we are getting WL square by 2. That is, we are writing WL square by 4 minus WL square divided by 8 here. So what is the value again? That is WL square by 8. Or got my point or not? So this is the value of maximum bending moment. So where the shear force is 0. So now I'm going to draw the bending moment diagram. So the bending moment diagram for UDL is nothing but parabola. Or got my point or not? So I'm going to take like this, like this. Here is 0, and at the center is maximum. That is the WL square by 8 positive. If you simplify it, we are getting positive. So I want to join this point and this point and this point. So by using a parabolic form. So I'm going to use a parabola like this. So this is the bending moment diagram for a simply supported beam which is subject to a point load here. That is UDL. That is not point load, UDL. Enter its length. So this is the way of drawing the shear force and bending moment. So we can draw directly also. But if you want to find the bending moment values or want to find the shear force values, we can follow the procedure now, what I am saying. Are you got it or not? Right. So this is the case number 2. So a beam is simply supported beam is subject to uh, UDL. So how to draw the shear force and bending moment values? You have to remember those values, the standard values, and the beam is subject to the next case number 3. I'm going to give it to you. That is nothing but a simply supported beam which is subjected to a uniformly varying load. This is the diagram for uniformly varying load. So this is the length of the beam. I'm going to take it here. This one is nothing but maximum load W per meter. Are you got it? Right. Here we are going to draw the shear force diagram and bend moment diagram. So before going to draw the shear force and bend moment diagram, you have to find the reactions at the supports now. So this reaction at point A, at point B, they will ask questions. What is the value of reaction at A? What is the value of reaction at B? What is the value of maximum shear force? What is the value of maximum bending moment? What is the diagram of shear force? What is the diagram of bending moment? They will ask any question. So that if any simply support beam is given, first of all, we are going to calculate what is the value of reactions. Are you got my point or not? Okay. Right. So here I'm taking this one is RA. So RA plus RB, those are two upward forces, both are acting in upward direction. Now, what is the total load here? What is the total load on the beam? Now, tell me here, this load is always acting downward direction. The total load is equal to area of the diagram, area of loading diagram, area of loading. So this load is in the form of triangle. So I'm writing here RA plus RB is equal to half into total base is nothing but L, height is nothing but W. We are getting WL by 2 is the value of total load. Then we are writing RA plus RB is equal to WL by 2 is the first equation. Now I'm going to find the second one, that is also in terms of RA and RB by taking the moment at any point is 0. So I'm taking here moment about A point is equal to 0. Then I'm writing here, here is RB into what is the total length here? L. Okay, right, that is positive. Why? Because that force is moving in upward direction. And next one, this total load is how much? Total load is nothing but WL by 2. That is also passing through center of gravity. And this distance is how much? L by 3. And distance is how much? 2L by 3. So I am writing here L by 3 multiplied by L by 3, which is negative is equal to 0. And here I want to find RB. RB is equal to WL square divided by 6. LL both are cancelled. Then we are getting RB is equal to WL by 6. If you substitute this value in this equation, then RA is equal to, we are getting WL by 3. So these are the true values of RA and RB. Are you got my point? Right, these are the RA and RB values. So I'm going to indicate those reactions. After that, I'm going to draw the shear force and bending diagrams automatically. So what is R and RB? So this one is nothing but WL by 3 and this one is nothing but WL by 6. So if you see the diagram where the load is more here, at that point we are having more reactive force. So this force is always more than this one. This one is less by 6, but here is by 3 only. So these are the two loads. So here I want to draw the shear force diagram first of all. So listen carefully. Okay. Right. So this is the shear force diagram. Now tell me anyone. So what is the shear force here now? So this one is moving in down or upward, but shear is in downward, WL by 6 here. And here is also we are getting WL by 3 here. And these two are joined by a profile. That is, in case of UVL, what is the shape of this one now? Parabolic form. So I'm going to join these two by this. Okay, this is a parabola. Okay, right. So this is the shear force diagram. So at a particular point, shear force must be equal to how much? You will find it very easily. Where the shear force is also 0. I will give it to you. Listen carefully. So in case of bending moment diagram, so simply we can draw like this. So this is the bending moment diagram. So bending moment at this point is also 0 and bending moment at this point is also 0. But at this point simply where bending moment is 0, shear force is 0 here and this is a cubic profile. So here is bending moment is maximum. So this is the cubic profile. The parabolic is nothing but more height. Okay, this is the cubic curve. I have already told you this is the bending moment diagram, this is the shear force diagram. But here, how to find those values where the shear force is 0, where we are getting bending moment is maximum. So here, uh, want to find the maximum bending moment value. So first of all, find the equation of shear and equate to 0. Then automatically we are getting what is the value of shear force and bending moment maximum values. Now listen carefully. I want to give it to you. The same concept we can use to find the contraflexure point also. That means between the supports, bending moment must be equal to 0. That point is nothing but contraflexure points. That is, the beam will changes its sign suddenly from positive to negative or negative to positive. That point is always named as contraflexure point. They will ask question on the beams, that is, how many contraflexure points for simply support beam, for cantilever beam, for overhanging beam. They will ask questions like this. With you one by one, one by one. First of all, listen carefully. So for this beam, I'm going to explain to you. So where the shear is zero and how to find maximum shear and how to find maximum bending moment. You got my point? So that general procedure, I'm going to cut this beam into two parts. I'm taking this one, that is, I'm going to draw here. This is the beam, right hand side. After cutting the beam, so this length is I'm going to taking as X, and this load we are going to know it. I already told you that is P is equal to WX by L. I already told you in case of UD, UVL, how to find by using these two similar triangles. I have already given to you. Okay. So this is the total load. The total load is always passing through which one? Total load is passing through which one? Center of gravity. Okay. All right. Now I'm going to draw the again freeway diagram here. Another reaction is also here now. This reaction we are having, that is WL by 6. And what is the total load here now? This is the triangle, which is in the form of triangle. Total load is nothing but half into base x into Wx by L. That is equal to Wx square by 2L. Half into base into height. Half into base is x. Height is nothing but Wx by L. That is, we can get Wx square by 2L. That is exactly acting at the center of gravity. So I want to find this at this point. What is the value of shear force? What is the value of bending moment? Listen carefully. Okay, and this length is how much? X by 3, and this one is 2x by 3 for triangle. Okay, just having an explanation. I have already told you how to draw the shear force and bending moment diagram. But if you want to find the maximum shear force and maximum bending moment, that's why I'm going to give it to you. Okay, so if you want to find the maximum shear force, maximum bending moment for any case, first you form the bending equation and form the shear force equation. After that, we are putting the boundary conditions. Automatically, you will get the maximum shear force value. So here, listen carefully. I want to find the shear force here. So shear force is equal to sum of upward forces and downward forces. What is the downward force here? That is Wx square by 2L, which is positive, minus WL by 6. Now, I want to find the shear force maximum and bending moment maximum. So when x equal to 0, what is the value of shear force here? That is minus WL by 6. I have already given at point A, what is the value of shear force? So when x equal to L, what is the shear force value? We are getting plus WL by 3. Check it now. Substitute x equal to L here, L both are cancelled, WL by 2 minus WL by 6, then we can get WL by 3. Right? So where we are getting the shear force is 0, that means W shear force is 0 means we are going to equate this one equal to 0. That is, I am writing Wx square by 2L minus WL by 6 equal to 0. If we equate it, automatically we can find it where the shear force is 0. That means at what length we are getting the shear force is 0 on the beam. So I am writing here from this one, Wx square divided by 2L is equal to WL by how much? 6. And this is 3 times is cancelled. This is L into L. W get cancelled. And x is equal to x square is equal to WL square by 3 we getting. So x equal to how much you get? X equal to L by root 3. L by root. That means at a distance of x equal to L by root 3, we are getting shear force is 0. We are getting shear force is 0. At the same time, we are getting the bending moment maximum value also. What is the equation for bending moment? Listen carefully. What is the value of bending moment here? Bending moment equation. See this one. Just I'm giving explanation. So we can draw the direct diagrams. I have already given to you. But if they will ask what is the value of shear force, what is the value of bending moment, that's why I'm going to explain to you. So here, bending moment is nothing but this force into this distance. That is WL by 6 into x. The total length is x. That is positive. And the minus Wx squared by 2L into this distance x by 3. Then I'm writing bending moment is equal to WLx divided by 6 minus Wx power 3 divided by 6 into L. Then tell me here, what is the value of bending moment at x equal to 0 at x equal to L? At x equal to 0, 0. At x equal to L is also 0. Or you get my point here. Then where the shear force is 0, that is shear force is 0, nothing but x equal to L by root 3. Shear force is 0, but bending moment is maximum. Shear force is 0, but bending moment is maximum. So substitute x equal to L by root 3 in the bending moment equation, then we are getting the bending moment is nothing but that is 9W. So that is WL square by 9 root 3. We are getting that value. So that is the, if you substitute x equal to L by root 3 in that equation, in the bending moment equation, then we are getting this value. This is the maximum bending moment value. So this is BM maximum, bending moment maximum. At that point, shear force equal to how much? 0. Or you got it? Right. So these are the simply support beam, which is subject to point load and UDL and UAL. Now I'm going to give it you explanation about when these beams are subjected to couple. Couple, listen carefully. That is very, very important gate point of view. So after that, I'll give the explanation about the overhang beams also. Okay. Right. So here I'm going to put heading. Beams are subjected to beams are subject to couple. Okay. So when the beaming, what is the first of all, what is the meaning of couple? If you know the definition and if you know the sign convention of the couple, automatically we can draw the shear force and bending moment diagram. Listen carefully. I'm going to give it to you. What is the definition of couple? Couple means equal and opposite forces acting at any point on the beam so that the beam may rotate either clockwise or anti-clockwise direction. Or you got my point? Equal and opposite forces acting at a point so that acting at a point on a beam so that it may rotate clockwise or anti-clockwise direction. That is the definition of couple. I'll give it to you. For example, if you take this is a couple, it will indicate like this. So this beam is subject to one force like this, one force like this. So this is the P value. So equal and opposite force are acting on a beam at a point. So due to these two forces, the beam may rotate in which direction here? Anti-clockwise direction. So here I'm going to indicate another beam here. So this one is acting in downward, this one is acting in upward, but both forces are having same magnitude so that the beam rotate in clockwise direction. So here I can indicate like this also. For example, if you take this is the beam, I'm taking one point here. I'm going to indicate like this. So this is also symbol for couple. That means at this point, so equal and opposite force are acting on the beam so that the beam may rotate either clockwise or anti-clockwise direction. So here, clockwise couple is always negative. It is always negative. Why? Because the beam is rotating in downward direction. There is moves in downward, but it is moves in upward direction. So anti-clockwise is positive and clockwise is negative. This is a sign convention for couple. Or you got my point or not? So what is the definition of couple here? Couple is nothing but equal and opposite forces acting at a point on a beam so that it may rotate clockwise or anti-clockwise direction. So if it is rotate clockwise direction, the couple must be negative. If it is rotate anti-clockwise direction, the couple must be positive. That is the sign convention of couple. Now I'm going to give it to you. So how to draw the shear force and bending moment diagram when this beam is subject to couple here. Or you got my point? Right. Listen carefully here. So all of you clear about this one now? That is what is couple, what is the sign convention of couple. So where we can take the couple is positive, where we can take the couple is negative. So if it is clear, then I'll give the explanation about the how to draw the shear force and bending moment diagram for different types of beams. So I have only explained two beams, cantilever beam and a simply support beam is over. Now I'm going to explain to you these two beams, that is simply support beam and cantilever beam, which is subject to a couple, how to draw the shear force and bending moment diagram. See this one. I'm doing the example problem. So this is one force is given, that is 5 kilonewtons, and this one is couple is given, that is 2 kilonewton meter. This is point A, this is point B, this is point C. Now this is the diagram is given to you. So now I am asking how to draw the shear force and bending moment diagram. If the couple is acting on the beam, couple is acting on the beam. If you want to draw the shear force diagram, don't consider the couple. Why? Because it is like a moment. It is also named as moment here. Or you got my point or not? Listen carefully. What is the definition of couple? Equal and opposite force are acting at a point on a beam so that the beam may rotate either clockwise or anti-clockwise direction. Or you got my point or not? So the couple is nothing but bending moment of individual forces. Individual forces. So, for example, this couple is acting like this. Then what happened here? This is rotating in this direction. This is P and this is P. And what is the distance between this length and L here? What is the moment of this force with respect to this one P into L? What is the moment of this one with respect to this one P into L? So, what is the meaning of couple here? Couple is nothing but bending moment of individual forces. If you take the bend moment of this force with respect to this one, or if you take the bend moment of this one with respect to this one, we get the same value. So that I am also telling like this. Couple is nothing but bending moment of individual forces which are acting at a point. Or you got my point or not? Right. So it is like a bending moment. So like it is a couple, or we can like bending moment of individual forces at that point. So here I'm going to draw the shear force diagram and bending moment diagram here. So very simply we can draw it. So this is the shear force. In case of shear force diagram, so there is no need to consider the couple. Why? Because shear force means we are going to consider force only. There is no consideration of moments. Or you get my point? So at this point, shear force is zero. But what is the shear force here now? 5 kilonewtons, but is moving in downward. So shear is upwards. So this is 5 kilonewtons. After this one is zero, there is no any shear. So shear force is zero here on this line up to point B. If you come to point B, there must be a force which is acting vertically downward, so that that force is 5 kilonewton. That is shear, and up to this one is continue constant. If you come to this one, it is becomes zero. If you consider the reaction at point A, this is the shear force diagram. Now I'm going to give it to you. What is the bending moment diagram? Have you got it? Now see this one. What is the bending moment diagram here? So in case of bending moment diagram, we are going to consider the couple. So now tell me what type of couple is acting here now? Clockwise. Clockwise positive or negative? It is a clockwise couple. It is also taken as bending moment. It is a clockwise. Clockwise always negative. So I'm going to take up to this one is how much? 2 minus 2 kilonewton meter is the couple. Right. So up to this one is same. Can get it? Now here, if you find this moment about this one is also same. Why? Because see this one. I'm going to take the moment here is 2 kilonewton meter. What is the bending moment here? This moment is zero, but there must be moment here now. I got my point or not? So I'm writing here bending moment at point B is equal to also 2 kilonewton meter. Or got my point? Now, same here. Both are same here. Same value we are getting. So at C, at B, both are having same bending moment value. It is also negative. Negative. So if you come to point A, I'm writing here bending moment at point A is equal to. So take this moment and take this couple also. So what is the moment here? 5 into, so take this one is 1 meter and this one is 1 meter. 5 into 1, negative. And the couple is also negative, that is 2. That is totally minus 7 kilonewton meter is the couple at point A. Or you get my point? So that is negative. Negative means I'm going to indicate up to this one. That is minus 7 kilonewton meter. Now I'm going to join by triangle, linear function. I got it. So this is the bending moment diagram. Up to this one is a rectangle. Up to this one is triangle. Bending moment diagram. Or you got my point? Or you got it? So this one is up to rectangle, and this one is triangle. Or you got my point? So this one is the couple here. That is minus 2 kilonewton meter. And here is bending moment is minus 7. So it is more than 2. Then I'm going to indicate it downward. This is the bending moment diagram with couple. Now I'm going to give one more example on cantilever beam with couple. So listen carefully how to draw the shear force and bending moment diagram. Now another example on cantilever beam. So this is the cantilever beam which is having a point load here and which is having a couple is here. The point load is 2 kilonewton meter, 2 kilonewton here. This is 1 kilonewton meter is the couple. So this is point A and this is point B. Now this total length is nothing but 2 meters. Now tell me how to draw the shear force and bending moment diagram. Shear force and bending moment diagram. So otherwise we can take like this also. We can take like this also. Here is another load. We are going to indicate this is 2 kilonewton, and we can draw another one here that is also 1 kilonewton meter. So this point is A and point is B and point is C. Now my question is how to draw the shear force and bending moment diagram for this cantilever beam, which is subject to point loads at the same time subject to couple. That is nothing but bending moment. So first of all, I'm going to draw shear force diagram. After that, I'll give the explanation how to draw the bending moment diagram. So here I'm going to draw the shear force diagram. So what is the shear force at point C now? If you want to draw the shear force diagram, don't consider the couples. I have already told you. Don't consider the couples. Then here, what I am saying here, force is moving in downward. So shear is in upward. That is up to this one is 2 kilonewtons. That is the shear force at C point. Now if you come to B point, if you come to B point, up to this one is shear is constant. If you come to point B, another force will add it, that is 2. That is 2 plus 2 becomes 4 kilonewtons here. And up to this one is same. And if you consider the reactive force, it becomes 0. So this is the shear force for this way. Now I want to find the bending moment. Now listen carefully. Listen carefully. That is very, very important. So most of the cases are given like that in the gate examination. So listen carefully. I'm writing individually. So what is the bending moment about C? Listen carefully. What is the bending moment about C without couple? With the couple, we can take 2 points here. With the couple, without couple. If you take the point C here, what is the bending moment? The bending moment of this force is 0, but there must be a couple. There must be a couple. The couple is not 0. Is it right or not? So this force is passing through this point. This moment is 0, but there must be a couple here. So how much couple here now? That is 1 kilo Newton meter, which is negative. Why? Because it is a clockwise couple. Why? Because it is a clockwise couple. Now I'm writing here. So bending moment about B. Listen carefully. B without couple. Without couple. Tell me now. I'm not considered without couple. After that, I'll consider the couple also. Listen carefully. What is the bending moment at point B without couple? Here. Here I'm saying without couple, not here. Already that is over. So I am taking about point B. I'm going to consider bending moment at point B without taking this couple. Now tell me here how much you get. That is 2 into this distance is how much? This is 2 meters. We can assume this is also 2 meters. Then here 2 meters into 2 meters, which is negative. Negative. This moment is over. And this couple is also there here. That is what is the couple here? Minus 1. And this moment is 0. Then how much you get here? Minus 4 minus 1, we can get minus 5. This is the bending moment about point B without taking the couple, without taking this couple. Now I am taking here. So bending moment about point B with the couple. With the couple. Without couple, how much you get it? Without couple, how much you get? That is 5 minus 5. And if you consider this couple, that is also minus 1, then totally minus 6 kilonewton meter. Are you got my point or not? Are you got it? Now, if you subtract these two, then we are getting the 1. That is the net value. What is the net couple? So let's listen carefully. Without couple, with couple. Without couple, with couple. Without couple, we are getting minus 5. With couple, we are getting minus 6. The difference between these two, we can get 1. 1 is the number net couple. That is the couplet point. Or you get my point or not? Now here, what is the bending moment at point A? So I'm writing here bending moment at point A. Bending moment at point A. Now take this one 2 into 4. 2 into 4 negative. This is 2 into 2 negative. And two couples. This is also a couple. This is also a couple. Both are anti-clockwise. Both are clockwise direction. So minus 1, minus 1. What is the total value here? We are getting minus 8, minus 4, minus 2. Then 12, 14. Now listen carefully. Now how to draw the shear bending moment diagram? That is the very, very important. So this is the bending moment diagram. Listen carefully. Now what is the bending moment here? That is minus 1. Right. What is the bending moment here? Bending moment here without couple here. So this one is bending moment is up to this one is same. Right. Now tell me here. What is the bending moment at a point B without couple? Without couple, how much? How much you get? Minus 5. And with couple, minus 6. I get my point or not? So I'm going to draw like this. Listen carefully here. So this is the value of bending moment about C, and I want to find the what is the bending moment about point. Initially, I am getting here minus 5 here, minus 5 here. That is without couple. With couple means we are getting minus 6. So this is the line I'm going to join here. This is the line I'm going to join here. So this is the couple varies from this point to this point, this point to this point. So when you come to point B without couple, point B having a moment of minus 5, with the couple at the same point, they are having minus 6. By subtracting these two, they are getting plus 1. That is minus 1. Then we are getting which one? Clockwise couple. Then here, what is the bending moment at point A here? At point A here, at point A we get minus 14. So here I am indicating minus 14 kilonewton meter. Then I am going to join here. What is this one here? This one indicates there must be a couple at point B. So this indicates there must be a couple at point B. This indicates also there must be a couple at a point B. Or you got my point or not? So this is the way of drawing the bending moment diagram for a cantilever beam which are subject to a point load and a couple. So this is the way of calculation. I'm going to give it one more example for simply support beam when the beam is having a couple which is acting on it now. Listen carefully. That is also given in gate examination. Listen carefully. So this is the simply support beam. So here one couple is given here. That is M. M is given, which is exactly acting at this center. This is L. This is exactly at the center. This is nothing but L by 2. This is L by 2. Here I am asking, so this is the simplest supported beam which is subject to a couple exactly at its center. Now, first of all, my question is, what is the direction of reactions at the support? What is the direction of reactions at the support? Or you got my point or not? Right, listen carefully. When the couple is acting clockwise or anti-clockwise here. So here this couple is always acting in clockwise. So the beam will bend in downward direction, like the beam will rotate in clockwise direction. When the beam is rotate in clockwise direction, this support will give a reactive force in upward. This will always give a reactive force in downward. Then these two are equal and opposite. Then the beam is said to be under equilibrium condition. Otherwise, we can take like this also. We can, if you don't know the direction, directly we can write RA plus RB must be is equal to how much? 0. And RA is equal to minus R. That means one is positive and one is negative. Why? Because there is no any vertical load here. Now here we don't know what is the sign convention here. Then we can take RA is positive, RB must be negative, or RB is positive, RA must be negative, or get my point or not. Now I know the directions here. That is RBs must be in upward direction and RAs must be in downward direction. These are the direction of reactions. Now how to find the magnitude of these reactions? How to find the magnitude of these reactions? So what is the reactions here? Listen carefully. We are getting RA is equal to minus RB. That is one relation. Or you get my point. So I want to find the another relation between RA and RB. So that I am writing here, take moment about A is equal to how much? 0. Take moment about A is equal to how much? 0. Then I am writing here RB into total length, that is positive. Why? Because RB is moving in upward direction, that is always positive moment. Then here, what is the couple now? Couple is clockwise. Clockwise nothing but negative, that is M is equal to how much? 0. Is equal to how much? 0. Then I am writing here RB is equal to M by L. This is positive. When RB we can substitute here, then RA is equal to minus M by L. Or you got my point or not? RA is equal to minus M by L. RB is equal to M by L, but both are having same magnitude M by L. It is also is equal to M by L. Or got my point or not? So 2 points is clear given to you. How to find the reactions at the support and what is its directions, and how to find the magnitude of RA and RB values when this beam is subject to couple. Or you got my point? Now third one, I am going to draw the shear force and bending moment diagram. Shear force and bending moment diagram. Or you got it? Right. Listen carefully. Now, what is the shear force here? This force is moving in upward, so shear is negative. So I can write here the M by L, that is negative. So up to this one is same. There is no any change of this one up to this one. So there is here, there is no force at point B, point C here. So we never consider the moment here in case of drawing the shear force. So up to this one is we are getting same value. And if we come to this one is becomes zero. So this one is we can take either positive ml, positive m by l or negative m by l, but directions are opposite, but magnitude is same. So this is the shape of the shear force diagram. So here is also we are getting plus W plus M by L here. So here I'm going to draw what is the bending moment diagram here. How to draw it now. That is the very important case. So listen carefully. So this point is I am saying C. What is the bending moment here? So a bending moment at the supports must be zero when the beam is said to be simply supported. So this value is zero. This value is also zero. So moment is zero here, zero here. I want to find the moment about C here. Listen carefully. I want to find the moment about C. So here I am writing moment about C, bending moment about C without couple, without couple. So how much you get now? So bending moment at point C without couple, there is nothing but that is M by L into L by 2. That is we are getting M by 2, M by 2. That is positive. I am writing here bending moment at C with couple, then without couple is m by 2. With couple is nothing but clockwise minus m. That is we are getting minus m by 2. This is negative. Now bending moment about a 0, automatically it is 0. So this is the bending moment about point B, point C without couple, with couple, that is clear to you. Now I am going to draw the bending moment diagram. So here bending moment is 0, 0. But about C, I am telling you without couple how much? Plus m by 2. So I am going to indicate this one is plus m by 2. Up to this one. Okay, this one. I am going to draw. Bending moment is triangle, the linear function. Now, but this one is without couple. With the couple, how much you get? Minus m by 2. So this one is nothing but minus m by 2. So net we are going to take it. So m by 2 plus, that is a difference between these two. That is nothing but m by 2 minus or m by 2. That is 2m by 2. Then we can get 2 to cancel. Then we are getting m. M is nothing but net couple here. So this value is also 0. So this is the bending moment diagram for the cantilever simply support beam when the beam is subject to a couple exactly at its center. Or you got my point or not? What is the indication of this one now? If you see this one, there must be a couple, that is M, that is net couple. Or you get my point or not? This is the value without couple, this is the value with couple. If you take the difference between these two, then we can get the given couple here, point B, point C. Or you got my point or not? Or you got it? Right. So this is the way of drawing uh, shear force diagram and minimum diagram. So I'll give one more problem. So remaining I will explain tomorrow. So that is next class. So listen carefully. This question is given gate examination. Now I'm going to explain question which is given gate examination. Please listen carefully. So this is the question is given like this. This is the question is given in the gate examination like this. So this is the beam which is placed simply like this. So here one load is given, that is 100 newtons, and the distance between this one and this one is given 100 mm, and the distance between this support and this center, this is 500 mm. It is also 500 mm. This is the given question. So on this question, they ask two questions. Each one carries 1 mark. So the first one is find the maximum bending moment and draw the bending moment diagram. Find the maximum bending moment here. And next one is nothing but bending moment diagram. Now here, this load is not acting exactly at the center. It is always away from the center. So it is named as eccentric load. So in such cases, in such cases, first of all, find the when the load is acting at this point, this load will also acting at this point. At this point also, it will transfer from this point to this point, this point, this point, this point, this point. That means this load will act at this point also. So I'm going to indicate here like this. This one is like this. See this one. This load will acting at this point also. At the same time, at the same time, due to this eccentric load, there must be a movement. There must be a movement here. So that is nothing but couple. So due to this eccentric load, there must be a couple will occur. That couple is nothing but also acting at this point. See this one. If this applies the movement in this direction, at this point, there must be a movement like this. So this is the movement clockwise. This is the anti-clockwise movement. Both are in equilibrium up to this portion. So if you come to this portion, if this moment is apply in this direction, this moment will apply in this direction. Or I got my point or not? That's why I'm indicating like this. Otherwise, we can directly take it. So if it is acting in this direction, so there must be a couple here also. So we can remove this one again. So we can take directly this diagram only. Or you got no point or not? Or you got it? So this one is how much now? So this couple is nothing but 100 into 100. This is 100 into 100. This is how much? 100 newtons. So then I'm going to remove this one now. So here, when the eccentric load is acting like this, so I'm going to transfer this force to this point. So force is applied at this point. It will also acting at this, at this, at this, at this also. So that it will passing through this point also. At the same time, due to this load, there must be a couple will develop. There must be a movement will develop. So that that couple is always in clockwise direction here. So here, first of all, we have to find the two reactions. So first of all, tell me the two reactions here. After that, we can find automatically what is the maximum bending moment and shear force and bending moment diagram also. Are you clear now? Now here, what are the reactions here? So for example, I am taking RA and this one is nothing but RB. So RA plus RB is equal to 100 newtons. RA plus RB is equal to 100 newtons. And take moment about A is equal to 0. That is the second one. Then I am writing RB into 1000. This is total distance. This is 500. This is also 500,000. And the next one is nothing but 100 into, it is positive. 100 into 500, it is negative. This is moving in downward. And last one, consider this couple also. What is the couple here? Couple is clockwise. Again, we can write 100 into how much? 100 is equal to how much? 0. Then I'm writing here RB into 1000 is equal to, that is 500 into 100 plus 100 into 100. Then how much we get now? That is 50000 plus 1000, 4 zeros. So that is RB into 1000. Or you got my point or not? Then we are getting here how much? 3 zeros, 3 zeros, 3 zeros. Then we can get 5 plus 6. Then RB is equal to how much? 60 newtons. If you get the RA is equal to 60 newtons, RB automatically, RA is nothing but 40. So here I'm writing 40 newtons. Here I am writing 60 newtons. So that is the way of calculation of reactions at point A and B. So this question is given gate examination. So take care about this one. So this is under eccentric load. So I'm going to convert into a point load and a couple at the center. Then I'm going to find the reaction at RE and RB value. Are you got my point or not? Right. Same thing here. How to draw the shear force diagram for this case now, and how to draw the wind moment for this case. I will give the explanation in the next class how to draw shear force and wind moment diagram for this. Well, after that, I will give the explanation about the overhang beams and remaining beams also. Right. So thank you very much for supporting me after this one. So if you have any doubts, please uh, follow all the previous questions and any materials, all the number of questions. Then we will get taken up. If you have any doubt, so please go through the basics now. Okay, how to find the shear force and bending moment when it is subject to point load, UDL, UVL, couple, and last one, another one is also that is internal hinge. I'll give it to you, so we can get the answer very easily. Okay, right. Thank you very much. I'm going to leave this class. So tomorrow we will meet. Thank you. Thank you.